folks, Mrs. White here. This is your second remote learning lesson of the week. I hope the first one went good. In that first one, you did have to review finding solutions to polynomials that were in the third degree. So if you're given a factor, can you divide it out? And then you get a resulting quadratic. Can you keep going and solve that quadratic? And the maze activity didn't really have you going that extra step to find the other two solutions. So as we do our reviewing for our test today, we want to make sure that we are doing that, okay? And we'll make sure to review it together also. So today we're going to cover several sections from your book. We're going to look at section 4.1. And in 4.1, we learned our exponent properties and how to simplify monomials using them. So we'll review that. In section 4.2, we're looking at computing with polynomials, so adding, subtracting, and multiplying. And then lastly, we're going to look at division as far as computing with polynomials. And we do that three different ways. Sometimes we have a poly divided by a mono, a poly divided by a poly, and we could do the poly divided by a poly with long division or synthetic substitution, or just synthetic division, excuse me. Our test is also going to cover the graphs of polynomials. So if I give you a polynomial equation, can you make a table and then a graph? And then from that table and graph, can you tell me if it was an odd function, an even function, how many zeros there are, their end behavior maybe, and turning points. So those are important notes to be looking over, and we'll review some of that briefly today. The last two sections focus around solving polynomials. So if you... Section 4.6 has you looking at specifically factoring polynomials, and factoring is a very specific strategy or a set of 6 strategies that don't always work but can sometimes work. And if they don't, then they're prime. So we'll go over those strategies and discuss what they are. And then the last section, which you again practiced last class, is the remainder of factor theorems, which is kind of taking that third degree polynomial and figuring out all 3 solutions. Your homework that I'm not really necessarily going to be collecting from you folks is to do whatever review that you need to do. There is a review sheet that your teachers put together. It looks a lot like the test as far as setup. Your test is going to be a lot of multiple choice questions, and so is the review. And Mrs. Boyce nicely made a key for you folks, so you're welcome to take a look at both of those items. They are going to be linked underneath this video. One special thing that I'm sure you've seen at this point is that we are allowing you folks to have one page and only one side of one page of notes, whatever you want to put on it from chapter 4 to use on your test. So what I would probably do is take a look at that review, pick out items that you know really well, do not plan on putting them on the sheet unless you have space to. Then go to the items that you maybe don't know super well or you definitely need to brush up on, and look back at your notes, look back at this video, and then make sure to add those pieces and parts into your one-sided note sheet, okay? It cannot be printed, it must be handwritten, and it cannot be anything that you found on the internet, okay? So this will have to be handed in with your test also. So let's get started actually reviewing stuff. We're gonna start with the oldest item, so section 4.1. So in section 4.1, we talked about computing with monomials and how we can use exponent properties to help us out. So we had a handful of properties. I'm going to say the names of them, even though it doesn't really matter to me if you know it, okay? So let's look at number 16 right here. So we have a mono times a mono. I know they're both monomials because there's no plus or minuses in between terms. They're just one big chunk times another big chunk. So we're going to treat this somewhat like constants at first. I'm going to take my 5 and I'm going to take my 4, both coefficients, and I'm going to multiply them together. And 5 times 4 is 20. Then I'm going to look at my variables. Again, it's one chunk times another. I have x to the third times x to the first. So this is the product rule. If you're multiplying like bases, you can add your exponents, okay? So since these are both the same variable, x to the third, x to the first, I can add those exponents. I end up with x to the fourth. And then my last piece, I have y to the negative 5, y to the 3. Again, I'm multiplying bases, so I add my 2 powers. So negative 5 plus 3 is negative 2. Now, when we're multiplying a mono and another mono, we stick it together to be one mono. okay? You should not have something plus something else or minus something else. It's going to be one chunk at the end. However, there is one more thing I could simplify here, and I hope that you all noticed it. When we have a negative exponent in our answer, we're not done yet, okay? Your constants have to be simplified. You should not have any repeat variables, and then negative powers need to have their position changed. So it's going to still have a 20 and an x to the fourth, but this y to the negative 2 is going to have to change its location. It's going to be moved to the denominator, and then the exponent becomes positive. Okay? So hopefully you could, if you want more practice on this, you could give 17 a try. It's very similar. Let's come over to number 19. Okay? So I'm going to start off with my constants. Up top I have a negative 1. In the bottom I have a positive 1. So negative 1 over positive 1 is just a negative 1. Okay? And I'm not going to put negative 1 up top. I'm going to pop a negative on the outside of my fraction. Next, and here's one of the other properties we haven't covered yet, when you have like bases being divided by each other, okay, and that's what I have here, y to the third divided by y squared, we take our powers and we subtract them, top minus bottom. So 3 minus 2 is 1. I'm going to have a y to the first power put in my numerator. My next part is z, and it's z to the fifth over z to the third. So 5 minus 3 is 2. I have z squared. Now, since there's no negative powers, I actually don't have to write a denominator. Okay, I don't have to simplify that out. So really, my answer is just negative yz squared. Okay, if we were to simplify that out. You can see that some of the fractions can get a little bit more complicated. Let's look at number 21. Okay, so we're going to start with our constants. 9 divided by 18 is going to be 1/2. I have a to the 7th over a to the 5th, which gives me a squared. B to the 5th over b to the 9th, so 5 minus 9 is going to be b to the negative 4. And then c to the 5th over c to the 3rd is c squared. Now from here you can see, all right, that can definitely have some simplifying. The 1 doesn't need to be there. A squared stays where it is in the numerator. Okay. This b has a negative 4, so I'm going to bring that down below. But the c has a positive exponent, so it's going to stay up top. So I'm going to, in the denominator, have a 2b to the positive 4. And this is my answer there. Okay. The last property that we're covering right here is power to a power. So what is it when you have something to the third power and then you raise it to the sixth power? So when we multiplied bases in this first problem, we added our powers. When we divided bases in the second problem, we subtracted powers. When we have a power to a power, we're going to multiply them. Okay? So if we're looking at 23, we have a z to the third raised to the sixth. So 3 times 6 is 18. This results in z to the 18th power. Boom, done. Now if you had several things in that parentheses, you need to make sure you multiply each of those exponents by the 6. Okay, you need to kind of distribute that exponent across. So this is pretty much section 4.1. Okay, it's our exponent properties. You're guaranteed to see 1, 2, maybe 3 of these on your test. Next, we had just simplifying or computing with polynomials. Okay, so that's going to include addition, it's going to include subtraction, it could have a little distributive property mixed with addition or subtraction. This is an example of a problem you could definitely see on there. I think it would benefit us maybe to do this problem together. If you want to do more, you can. I'm happy to do any of these with you also during office hours if you want to on Friday. So, or excuse me, on Thursday, so tomorrow. Let's start by just going over 34, and if you feel like you want to do more, you can come back tomorrow and we can talk about it. So, first things off, I notice I have multiplication and I have subtraction. So I'm going to simplify each of these polys right here first by distributing those coefficients across. So I'm going to send my 4 here and here and here, and I'm going to get 4a squared plus 4 times 5 is 20, a, and then 4 times negative 6 is negative 24. Then I'm going to take this 3, but I'm not going to really take the 3. I'm going to take a negative 3 and distribute that across. Because part of the subtraction piece, folks, is that you distribute the negative, so we might as well just send it across with the 3. So negative 3 times 2 is going to be a negative 6a to the third. Negative 3 times 4 is going to be negative 12a. And negative 3 times negative 5 is positive 15. Now I'm just going to, as my last step, combine like terms, okay? And when we combine like terms, you're adding and subtracting. You do not change your exponent powers, okay? You just add and subtract your leading coefficients, or excuse me, just your coefficients in general. So I'm going to put this polynomial that I have going on right here in standard form, which means I'm going to list it highest to lowest power. So my highest exponent is negative 6a to the third. My next highest exponent is a 4a squared, so it's positive. Then I have a 20a and a negative 12a, so combined I have a positive 8a. And then lastly I have a negative 24 and a positive 15, so those are different signs subtract. I'm going to end up with a negative 9 there. And this is my answer, okay? So I distributed whatever I had to outside the parentheses. If it was addition, I could distribute a positive 3. If it's subtraction, I need to make sure I send across the negative. And that really covers adding and subtracting. That's part of section 4.2. But what is also part of section 4.2 is multiplying. So you could have a mono times a poly. You could have a poly times a poly, okay? Or you could even have two pieces, right? A binomial times another binomial. So this is pretty much just distributive property like crazy, or double distributive property. We did this in Algebra 1. A lot of the stuff we're covering up till after this was all Algebra 1. So let's just do maybe 30 and 32. We'll go quick. In 30, I'm just going to distribute this monomial inside. My constant here is 1, so 3 times 1 is 3. N, there's no n in this number, so it's just going to stay in n, and then p times p is p squared. 3 times negative 1 here is going to be a negative 3, and then there's no p and no z, so it's just going to be pz. They are not like terms, so I'm done. In the next one, I see that I don't have a monomial, I have a poly. So I'm going to send this here, here, and here. Then I'm going to take that y and I'm going to send it here, here, and here also. So I'm going to end up with 6 pieces that I'm then going to simplify down. So let's start off with our x. And this is where some of our exponent properties are going to come in handy. So x to the first times x squared, those are multiplying like bases. So I add the powers, I get x to the third. X to the first times 2xy is going to be a positive 2, and then x times x is x squared, y. And then x times y squared is just going to be a positive xy squared. In the second piece here, I'm going to distribute not just a y, but a negative y. So x squared times negative y is going to be negative x squared y, or you could put y squared x, it doesn't matter. Excuse me. You could put y x squared. The squared has to be attached to the x on this one, though. Then we have negative y times 2xy. So negative times a positive 2 is negative 2. The x stays the same, but we have y times y, so it's going to be 2xy squared. And then lastly, we have negative y times positive y squared, so it's going to be a negative y to the third because I add my exponents. Now, from here, to put it in standard form, you should go highest to lowest powers, but a lot of the times in your book, you're going to have one exponent, one variable's highest power, like x to the third, and then on the other side, you're going to walk your way over to the y to the third piece, okay? So that's what we're going to do in this instance. We're going to go highest power of 3, all the way down to no power with x, and then up to our y power of 3. So our next highest power of x is this 2x squared. There happens to also be another x squared here with a y, which means that we can combine like terms on both of those. So I have 2 of this combination. I have a negative 1 of the same combination. That equals a positive 1 x squared y. Then I have an x to the first and a y squared, and I have an x to the first and a y squared here. So in this one, I know it's hard to see because I wrote over it. It's a plus, okay? So in this problem, I have 1, and I have a negative 2, so positive 1 and negative 2 is negative 1 xy squared. And then now I'm ready to just bring down my minus y to the third. This is my answer, okay? I double distributed. and then I combined like terms, remembering when I combine like terms, I'm only changing and adding and subtracting those coefficients, those numbers in front. So now we're ready to talk about some of the stuff that was totally new to you folks this year as far as like math skills, right? So we've never done dividing polynomials. We had done adding, subtracting, and multiplying at the end of Algebra 1, but never dividing. So there are a few ways we did this. We divided by a poly by a mono, and then if it was a poly divided by a poly, you had two strategies you could use, long division and synthetic. And I will tell you, if it does not specify which strategy to use on your test, it doesn't matter to me. But if it does specify which strategy to use on the test, I will be looking at your scrap work, and I do want you to show me that you know that strategy, okay? I will give you partial credit for getting the correct answer, but I will not give you full credit. So, dividing by a monomial, that's kind of like this number 25 here, okay? So up top I have a poly. I know it's a poly because it's separated by plus or minuses. And then the denominator is one chunk, so it's a mono. The strategy to go for solving this, and we're just going to solve this one quickly, is to distribute this denominator underneath each of these pieces and just use our exponent properties to solve. So it becomes 12x to the fourth y to the fifth over 4xy to the fifth. Then I'm going to put a plus sign. And I'm going to put this chunk now, 8x to the third y to the seventh. So 8x to the third y to the seventh over 4xy to the fifth. And then we're at our last piece here, which is going to be a minus, because this is a negative, 16x squared y to the sixth over 4xy to the fifth. Now each of these is just a little division problem to simplify. So 12 divided by 4 is going to give me a 3. X to the fourth over x to the first. I subtract, I get x to the third. The y's cancel. Now I'm going to put a plus because I had a plus here. 8 divided by 4 is 2. X to the third over x to the first is going to be an x squared. Y to the seventh over y to the fifth is going to be a y squared, again subtracting top from bottom. 16 divided by 4 is going to give me 4. X squared over x to the first gives me x. And then y to the sixth over y to the fifth is just going to be a y to the first. The last step is just to double check that you can't combine like terms here, and there's no combinations that match. So boom, I'm done. Okay. Next, we have long division and synthetic division. All three of these are poly divided by a poly. Okay, each of these are more than one piece, and all of them are division problems. So let's do long division with this first one. Okay, so we're going to take our divisor, we're going to pop it out front, y plus 2. And then inside our division symbol, we're going to rewrite this whole polynomial here, and we need to make sure we have every power included from highest to lowest, and if we don't have a power included, we need to add a filler. So a power of 3, a power of 2, a power of 1, and a power of none. I don't need to add a filler. So I'm just going to rewrite that in here. 6y to the third plus 13y squared minus 10y minus 24. Now I am going to go a little quick because we're not learning this, we're just reviewing it. The way to do long division is I look here and I look here, and I ask myself, what can I multiply this by so that it looks exactly like this? And that's going to be a 6 and a y squared. And then I'm going to distribute that through to both pieces. So 6y squared times y is going to be 6y to the third. 6y squared times 2 is going to be positive 12y squareds. Now at this point I need to subtract both pieces, which means I change this sign and this sign. Do not forget to distribute it across. 13 minus 12 is going to be just a positive 1y squared. I'm going to bring down my next piece. And I continue the same process. I'm going to ask myself, how does y become y squared? Well, I would multiply it by a positive y. I'm going to distribute that positive y across to both of these parts. So y times y is y squared again. Y times 2 is 2y. I'm going to now, hopefully you're answering this to yourself, subtract. These cancel. That should happen every time. And negative 10 minus 2 is negative 12y. I'm going to bring down my minus 24. Now I'm at my last part because there's nothing else to bring down after this. How can I make y look like negative 12y? Well, I just multiply that y by negative 12, and I'm going to distribute that negative 12 across now. So I end up with negative 12y, negative times a positive is a negative, and 24. I'm going to intentionally change both signs. These cancel. Negative 24 plus 24 is 0. That means we have no remainder. Okay, this divided nicely. And if you think to what we now know, that means that y plus 2 is a factor if we have no remainder. It divided nicely. Our answer to this division problem, though, is right up top, right there. Now, in synthetic division, it's a little bit of what I was calling magic math, because it's a really cool algorithm and pattern that works, even though it doesn't seem like it makes much sense. So let's look at 27 over here. I want to remind you folks that a negative power means you change its location, and that negative power is attached just to this parentheses. So that means that number 27 could be rewritten as a to the 4th plus 5a to the 3rd plus 2a squared minus 6a plus 4 all over this piece, right? Because this negative 1 means move its direction, or change its location, move it below. And if you see it like this, you should know, oh, that's a poly divided by another poly. So to review this one, we'll do synthetic. We need to find our R value, or our number in the box. And our number in the box here is always the opposite sign of this number here. So it's going to be a negative 2. Across the top here, I'm going to put all of the coefficients for my equation, my numerator, making sure that I have every power included. So 4, 3, 2, 1, and none. Good. I'm going to put all my coefficients and then my constant. So a to the 4th has a 1 in front of it. Then a 5 is my next coefficient. Then positive 2. Then negative 6. And then my constant here is a positive 4. Right next to the 4, I'm going to put a line here and here. That tells me this is going to be my remainder. So to start this, and again, I'm going quick because this should just be a review. I'm going to drop the 1. Negative 2 times 1 is negative 2. Now I combine like terms. 5 and negative 2 is 3. I'm going to multiply and get negative 6. 2 and negative 6 is negative 4. I'm going to multiply again. Negative 4 times negative 2 is positive 8. Negative 6 and positive 8 together is 2. And negative 2 times 2 is negative 4. And it happens to be that there's no remainder again. Now, if we were to write this answer out, I'm going to look, my original problem was a 4th degree. That means my answer is going to be 1 degree less. So it's going to be a 1a to the 3rd plus 3a squared minus 4a plus 2. Now, I do not have a remainder here. I thought I did in this problem, but I guess I don't. If you did have a remainder, okay? So at this point, this is really the right answer. But let's say, just for fun and for sake of review, that our remainder was 10, okay? We would then take this positive 10, it's positive, so I put a plus, and put 10 over my original divisor, which is a plus 2. And then this would be my whole answer if I had had a remainder, okay? We always take that constant and we put it over our divisor. So that's long division in a nutshell. You're guaranteed, I think, to see like 3 of those, okay? Some are multiple choice when it comes to that. 2 of them are not, and I require that you show both long division and synthetic. Next, we have analyzing graphs of polynomials. I actually have one of the problems from your review that is more like what you might see on the test, so we might chit-chat about that one a little bit more. You are going to be asked to do a handful of things. You may be asked to graph a function by making a table, okay? It's not just going to be like make a random table like in these 3 problems. I will give you a started XY chart with specific X values in it. That way you know how far you have to go, okay? You don't just make a random one until it feels like you should stop. You'd solve for each of those values and plug them in for your Y's, okay? Next, and you're guaranteed to see this, I want to be very clear, determine the consecutive integer values of x between a 0 where each 0 is located. A 0 is also known as an x-intercept, okay? So an x-intercept usually is going to happen between 2 numbers. If it does, you would say between x equals 2 and 3, or between x equals negative 1 and negative 4. And we can talk about that with an example in the future. It also asks you to estimate where the relative max and mins are. Relative means it's not going to be a total max and min. If we're dealing with a polynomial, let's say we're dealing with this one. Okay, and let's say maybe it looks like this on our graph. Relative maximum and minimums are going to occur at little peaks and little valleys. So a relative maximum would be here and here, both of them. Even if this one was a little bit higher, you still would have a relative maximum here and here. And then you'd have a relative minimum at that little valley below, okay? One thing that is not mentioned in this list that you are going to be asked to do is going to be end behavior. And end behavior always starts with as your x goes towards positive infinity and as your x goes towards negative infinity. And then we look at what's going on in your range. So in this specific graph, as x goes towards positive infinity, which means as we come out this way, our graph is going down, right? That means our y values are going to negative infinity. As x goes to negative infinity, our y is going down again, okay? So our y is going towards negative infinity also. If we were to be asked how many zeros this has, it's every time it hits the x-axis. So it hits the x 1, 2, 3, 4. If it hits an even amount of times, it would be an even function. The next skill we're going to look at is going to be solving polynomial equations, okay? So we're not going to focus on this strategy down here, this word problem. We decided to take word problems right out of your exam to make it a little bit better. And a little bit more digestible since we're not going to be there with you to help answer questions. But you are going to see potentially a couple problems that have to do with factoring. And this is the strategies that we learned and put in our flip chart. So there are things like greatest common factor, difference of squares, difference of cubes. It could also be a sum of cubes. We could have grouping, okay? And those are really some of the big focuses that we had this chapter. I know I spent a couple classes just going over it with you folks, okay? So, greatest common factor, you're going to do every single time, okay? You're going to look at whatever polynomial you're given, and you're going to see, can I divide something out of everything? And if the answer is yes, you need to do it. Difference of squares happens when you have two pieces and they're both perfect squares, okay? And the shortcut for that, if it is a difference of squares, is that you square root each chunk and you're left with a plus b and a minus b. With a sum of cubes and a difference of cubes, it's going to look like it's two pieces again from the get-go, but they're both going to be perfect cubes, which means that you can pull a cube or cube root each chunk, okay? And if it's a sum, it's going to have an a plus a b. If it's a difference, it's going to have an a minus a b. And then the next piece in both of these is going to be a trinomial. So it's going to have an a squared, and then if this is a plus, this has to be a minus, ab plus b squared. And then our next one is going to start the same way. It's going to have an a squared, but if this is a minus, it's going to be a plus ab plus b squared. And again, this is just a review. It's something you folks should already be familiar with. Grouping is going to happen when you have 4 or more pieces or parts, okay? And you're going to group them into equal groups and GCF each chunk. So let's take a look at, let's do this first problem right here, okay? So I notice right off the bat that it's 2 pieces, and I'm going to look at each of these chunks right now. There's nothing that I can divide out of a to the 4th and 16. Now, if this had a 4 in front or a 2 in front, I could divide 2 out of both. If this had an a squared with it, I could pull an a squared out of both. However, they don't have the same variables, and since this one only has a coefficient of 1, I can't divide it by another coefficient. I do notice now, besides the fact that I can't greatest common factor it, that it is a difference, and it looks like they could be 2 squares. I know 16 is a perfect square. So I'm going to rewrite it over here and put some work. So I have a to the 4th minus 16. It's a difference, and it appears to be 2 squares. So I'm going to double check it by pulling a squared out of each. So when I do that, I'm going to ask myself, what times itself is a to the 4th? And a squared times a squared is going to be a to the 4th, so I can square root it by putting it there. And then what times itself is 16? Well, that's easy, it's 4. Because I could break a squared out of each piece, folks, that means this is a difference of squares. I'm going to treat this as my a and this is my b. And now I just plug it right into all the a's and b's in each of this over here. So I'm going to end up with a squared plus 4, a squared minus 4. Now, something we've spent some time talking about in class is that if you have a power higher than 1, you need to check again if you can do anything with it. So I notice this is an a squared, okay? So I feel like it's a perfect square or something, and I know that's a perfect square, but it needs to be a difference of squares to be anything, so I actually can't simplify this. However, here, this is a difference, and I'm pretty sure both these are perfect squares because a times a is a squared and 2 times 2 is 4. So I'm going to treat this a squared as my a, or this, excuse me, this a is a, this 2 is b. I still have this chunk, a squared plus 4. Now I'm going to split this into 2 pieces using this same strategy above. So I'm going to have a plus 2 and a minus 2. And that now, folks, is as simplified as it can get. I had to do a difference of squares twice. You may feel, maybe we should take a look at another one. I don't want to spend too much time on these, especially if you're feeling good about it. This problem, I notice in 45, there's a lot going on. I think I can divide, excuse me, each piece by 4, nope, by 2. And I can divide each piece by, there's a y in both, so I can do it by my lowest power, just a y. So if I were to start solving this one, I can GCF out a 2y, and I'm left with 27 x to the third minus 8 y to the third. Now I notice this is 2 pieces, and I notice it's a difference, so I ask myself, is it a difference of squares or is it a difference of cubes? Well, looking at those powers, they're both 3, okay, so I'm thinking it's a difference of cubes. I'm going to pull a cube on the outside. The cube root of 27 is 3, and the cube root of x to the third is x. The cube root of 8 is 2, and the cube root of y to the third is y. So this becomes my a, and this becomes my b. So I still have this 2y from the beginning. I'm just going to bring my work down here. Okay, I still have that 2y from the beginning. Now I'm going to take my a and my b, and I'm going to follow this strategy right here for difference of squares. So I'm going to have a minus b first, so 3x minus 2y. Then I'm going to do a squared, so 3x times 3x, which is 9x squared. Then I'm going to add a times b, so 3x times 2y, which is going to be 6xy. And then lastly, I'm going to put a plus, and I'm going to have a b squared, so it's going to be 2y times 2y, or 4y squared. I am done. So I did both GCF it, and then this was a difference of cubes. The last problem I do want to discuss is this last one. I notice right off the bat that it's many pieces. That makes me think I'm definitely going to be grouping it. Okay. If I look, all 3 of these have a y in them, and all 3 of these have a z in them. So this, all 3 of these pieces can be divisible by 2 and y. So I'm just going to bring that down here. Up here, it's going to be left with a 3a. If I divide that out, if I divide by 2, I get, or take the 4 and divide by 2, I get 2. And then a b because the y cancels, so plus 2b. And then if I divide this by 2y, the 2's cancel, the y's cancel, I'm just left with minus c. Now the other piece, it is factorable by grouping. When I divide everything out of this, it should be the exact same in parentheses as that. So I'm going to start by dividing out just a z. I'm going to be left with 3a plus 2b minus c. Since these 2 things match, I know that it's factorable. My answer is going to be the outside, which is 2y plus 2, times 3a plus 2b minus c. The last thing for this chapter, you practiced it a little bit last remote lesson, but now we need to practice the whole thing. It is, if you're given a polynomial and one of the factors, you need to actually find the remaining factors. Okay, so you have to divide it out and then either factor the resulting polynomial or use quadratic formula to figure it out. So let's take a look at these 3 examples. In my first one, they're telling me this is already a factor. I would know that it's a factor by dividing it out if there's no remainder or the remainder is 0. So I'm going to divide this from the polynomial they gave me. I'm going to put my number in the box as being -5. And then power of 3, power of 2, power of 1, and power of none. I'm just going to put all my coefficients, 3, 20, 23, and -10. So I'm going to drop my 3. And -5 times 3 is -15. 20 and -15 is 5. -5 and 5 is -25. -25 and 23 is -2. -2 times -5 is +10. The remainder is 0. In order for something to be a factor, the remainder has to be 0. Since this was a third-degree polynomial from the beginning, I'm going to start by going down a power. So this is going to have an x squared, and then an x, and then it's going to be left with that -2. So now I just proved that this is one of my 3 factors. I need to find the other 2 factors. So to do that, I'm going to take this, which is just a quadratic, and solve it. And I'm either going to factor it, or I'm going to use the quadratic formula. Okay? So to factor it, I'm going to make this little table and ask myself what multiplies to be a times c and adds to be b. So what multiplies to be -6 and adds to be 5. And I know that 6 times -1 is going to equal -6, but add to be 5. So I'm going to take this quadratic and I'm going to expand it into 4 pieces and then continue factoring it. So I'll have 3x squared, and then instead of plus 5x, I'm going to put plus 6x minus 1x, and then minus 2. Now I'm going to group this, and I'm going to divide 3x from each. I'm going to be left with x plus 2, which is very close to this. I just have to divide each of these by -1. My last step is to rewrite it in this factored form, 3x minus 1 and x plus 2. And now I found the remaining factors. If you wanted to solve this, if it said to solve it, you would set each one equal to 0 and solve. So I would minus 2, I would get x equals -2. I would add 1, divide by 3, and I would get that x also equals 1/3. So those are my 2 solutions if I'm asked to solve it. These 2 right here is my 2 factors if I'm asked to find the factors. Let's take a look at this number 60 here, and then we'll go over the directions for your review sheet if you're so interested in getting a little extra practice. So I'm going to do the same thing here. I'm going to put my number in a box, which happens to be +5. It has a power of 3, a power of 2, a power of 1, and none. So I'm going to put just my coefficients, 1, 2, -23, and -60. I'm going to drop the 1. 1 times 5 is 5. 2 plus 5 is 7. 5 times 7 is 35. And 35 minus 23 is going to give me 12. 12 times 5 is 60, and 60 plus -60 is nothing. Again, because I got 0 as my remainder, I know that this is a factor. It divided nicely. It was a 3rd degree, so I'm going to put an x squared plus x. And now I'm going to check for factoring. So I'm going to ask myself what multiplies to be a times c and adds to be b. So what multiplies to be 12 and adds to be 7? And right off the top of my head, I'm thinking, I was thinking 6 and 2, but I really should have been thinking 3 and 4. Okay, they multiply to be 12 and add to be 7. Now, let's just review splitting this into 4 pieces. If you remember the shortcut that you could use, because a is 1 here, that's great, but that doesn't work every time. So let's just continue reviewing how to do it when we don't have an a value of 1. So I'm going to expand it into 4 parts. And that was a plus there because it was a +12. I'm going to group. I'm going to divide. Then I'm going to do the same thing here. I'm going to see that I can divide each piece by 4. I'll have a 4 on the outside and an x plus 3. My factored form is then going to be x plus 4 and x plus 3. Okay? So So this covers everything, and I know it's a lot that you could potentially see on that test, but I want to remind you, you do get one side of a normal piece of notebook paper. So an 8x11, if you want to use printer paper, if you want to just use line paper, that's fine too. You're more than welcome to create whatever you think is going to help you, okay? You cannot use your flip book. You can take whatever information from that flip book and put it on your paper. That's fine with us, okay? That is the same rule for all Algebra 2 college prep courses. So the review sheet is set up similarly. It actually was last year's test. We redid it this year. So you can see you're going to have a couple problems that are exponent rules. That's these first two here. This is section 4.1. You're going to have a couple problems that are going to be adding, subtracting, and multiplying. So we have 3 of those here. That's section 4.2. Now I do want to point out this just means that you are doing 5x minus 4 times itself, right? If something is squared and it's a binomial, you have to times it by itself. So it's going to be times 5x minus 4. And then you'll double distribute that. Okay? And then the last part of this, front little section is division, division, division. I do want to remind you that if there's a negative one on the outside, that also means division, right? If we see that with a binomial here. And that was section 4.3. Okay? After that, we saw some examples that had to do with graphing. Okay? You could be potentially given a graph, asked to do end behavior, figure out if it's odd or even, and then determine if the leading coefficient is positive or negative. So that has a lot to do with your end behavior. Okay? If the general trend is that it's going up left to right, then it would be a positive leading coefficient. If the general trend is that maybe it starts by going up, but it ends by going down, regardless what happens in the middle, the overarching trend is that it's ending negatively, so that would be a negative leading coefficient. And you're more than welcome to look at your notes from section 4.4 or 4.5. I think it was a 2-sided sheet, if you need some clarification on that stuff. Again, one where you might have to do some PEMDASing, so you'd take this equation here, plug it into the table, determine the x values where the zeros are located, and remember zeros are x-intercepts. Again, section 4.4, 4.5 are going to have some more examples of this, and that also includes our relative maximum and relative minimum. Okay. Then you could have some factoring problems. So this is like a section, I think it was what, 4.6, okay, where we would be using our flip book to look at these. I will tell you, even though you might feel like something is prime, on your test, none of the problems are going to be prime, so do not write prime in. And then our last section is going to be 4.8, which is going to be if we give you one factor, can you find the remaining other factors, okay? So there's 3 examples for that. I'm sure you're noticing right now that a lot of this test is going to be multiple choice. That's something that we also agreed on. We're going to make the majority of problems multiple choice to kind of help you out. But some of the odd even stuff, those are just things that you're going to need to be able to recognize, okay? So if you have any questions, again, please feel free to see me during office hours tomorrow. I would love to go over any of the stuff that you want to. Specific problems from this review sheet are up for grabs, but again, I am going to post the key underneath it. If you feel like you're going to wait till Sunday night to review this, that is fine, but I want to be very clear with you folks that I'm not going to be available for you on Sunday night, okay? So I have office hours on Thursday. If you take Thursday to work on it, and you realize on Friday that maybe you need a little bit of help, I will be reachable on Friday, but I am not going to be reachable to help you study over the weekend, okay? So take advantage of the times that I am available to you, and we can answer questions and clarify as needed. I will be getting in touch with everyone's parents, probably within the next 24, 48 hours, either via email if they responded to my original posting, or by giving them a call to make sure that we can set up a test time that will work for you next week. You will not have a lesson on Monday. Instead, I'm planning on you folks using that hour-long class time to be working on and finishing this test. So please have your one-page note sheet ready and raring for Monday when your parent approaches you. Okay, if Monday doesn't work, Tuesday's fine. I'm hoping that it will all be done before our lesson on Wednesday, though. Be in touch. Stay happy, stay healthy, and